on Q&A and discussion. I will try to see if we can get more Q&A time. With that, I'm going to start my presentation. So Spark, anybody who is into the data science or big data and anything related to intelligence, analytics, most of the developers and analysts, they might have heard Hadoop and Spark, these two words. My focus today is Spark, why Spark, and how Spark is changing the dynamics of data analytics. So if you look into what is happening in the market, there is a clear interest. The database, between database and big data, we can see after 2013, the big data interest is picking up a lot. This is kind of like a Google trends from the Google. So big data is clearly picking up. And then out of big data, there are so many open source projects that are really exciting and innovating in this space. But out of all of them, Spark is clearly seems to be getting a lot of attention. From the activity, number of commits, also from the job trends, it clearly seems Spark is one of the topmost open source projects out there. So what is Spark? So Spark, Hadoop, if we look into Hadoop, made a lot of big data storage much easier and cheaper when compared to the existing systems. Hadoop came with MapReduce, but MapReduce has its own, I would call, constraints. The Spark is making Hadoop much more successful by eliminating the bottlenecks and the constraints we have with MapReduce. So in few words, Spark is an open source in-memory application framework for distributed data processing and iterative analysis on massive data volumes. So the key things that Spark is addressing is, one is in-memory and works on distributed data. And if you have to do machine learning and have to do a lot of iterations, Spark is the best framework. And again, it's evolving like it's an operating system for analytics. And the reason why we say that is you can do batch analytics, you can do interactive analytics, you can do with Spark near real-time analytics. So it is becoming a tool for multiple use cases, near real-time, batch, and interactive, which no other framework has done successfully so far. So the way we see it is, okay, hey, this is going to enable multiple use cases with a single framework and toolset. So why is this increased interest in Spark? The benefits really we look at, Spark is, when compared to the MapReduce, the performance absolutely is, you see the comparison minimum 20 times to 100x faster in the tasks when compared to the big data and big data processing, any other processing frameworks. And then the language, the way it is built, it is very concise, very expressive, and single programming model would work for different use cases. And also it gives polyglot architecture where you can use the language that you want. You can use Python, Scala, Java, R. So you can use the language that your team prefers or your data scientist wants to do. And also the community activity is creating new tools on top of SQL at a rapid pace. And also the best piece is you can use existing Hadoop ecosystem. If your company has invested into Hadoop, you can. Along with that, what you can do with Spark is not only Hadoop, you can use any other data source as part of your analytical process. And as we see, the community is inventing so much as every day progresses, we see a lot more tools, a lot more capabilities coming under the Spark hood. So if you look into what is Spark, so Spark mainly has a core engine that can connect to many number of data sources or data storage mechanisms, I call. So if you look into it, can connect to Big Insights, Cloud and DashDB, Redis, Cassandra, MongoDB, Salesforce. So it can connect to any data source. And on top of it, you can use Spark SQL, Spark Streaming, Machine Learning, GraphX, and Spark Car packages to build your applications and do your analytics. So if we clearly look into Spark SQL, clearly positions with who want I want to run an interactive query and get results. You can use Spark SQL. Hey, I want to run near real-time streaming. Most of it's not real-time. It's near real-time. It depends on the use case. Most of the applications would work with near real-time streaming. So you could do that with Spark. And a lot of excitement is in machine learning. So machine learning and predictive analytics in a lot of organizations, you can, Spark effectively covers a lot of fundamental algorithms and statistical algorithms. And also the library is increasing at a rapid pace. Similarly, if you want to do any graph-like processing, like you can using Spark, you can. And then Spark Car is a statistical programming language, which a lot of data scientists use. That fits into the Spark without any issues. So if you look into connectivity to many data sources, and then expressive language, and then couple of lazy loading concepts the Spark core brings in with Spark SQL, Spark Streaming, Machine Learning, GraphX, and Spark Car, it's a powerful tool for data scientists and data engineers and any analytical team that they want to build analytical applications with. And if we look into how the usage is in the right now, Spark SQL, again, around 69% of the usage is in the Spark SQL, and 62 data frames, Spark Streaming 58, Machine Learning GraphX 58% of the community is using it. But if you look at the key metrics, is 75% of users are using more than one component. So again, that speaks the interest in the Spark from the community. And the other key important piece is multiple languages: Scala, Java, Python, and R, and probably it's going to support many other languages as we move on. So again, investments, the company's investments are protected. If the company has invested into Java programming language, they can use Java. If they're Python developers, they can. And if the data scientists are R, they can. If they want to use in a mixed mode, they can. So their investments are protected because of the Spark. And also the data frames framework that was built from R and Python is also really being very attractive to data scientists. So another important piece out of the Spark and then Spark ecosystem is a tool called a notebook. So notebooks are new tools that are getting rave reviews from data scientists, and many, mainly data scientist communities very much behind these notebooks. They, again, when you compare them with pen and paper, they're almost similar to pen and paper. What you can do with them is, hey, I want to, using notebooks, I want to show the data. I want to show my thoughts. I want to show some mathematics behind it, or I want to show visual results of what I am doing, and I want to collaborate with people. So notebooks are becoming very important in bringing all of them together: collaboration, visualization, presentation, and also looking at my models. And the notebooks are web-based. Mainly there are two notebooks. One is Zeppelin, which is Apache Foundation open source, and another is Jupyter. Here with IBM, we have went with Jupyter for the time being. Zeppelin is also going to be part of our data science experience, but for the for the time being, we initially started with Jupyter, which I'm going to demonstrate in my data science experience presentation later on. So taking a step back, we covered generally why Spark is, and then I'm going to spend a few minutes what IBM is doing in the Spark space, and then we will try to spend time on the key core concepts. So IBM is taking Spark and adopting Spark into their strategy, and it's really doing mainly three areas. One is it's contributing to the core, means there are a lot of developers from IBM. They're working with the open source community to enhance the Spark and then many other libraries. So one key contribution was there is a system ML, which is a machine learning language library, which was open sourced from IBM. And it is partnering with Databricks. Databricks is the, as you know, Databricks is the founder of Spark. And they are, so IBM is partnering with them to make the Spark core much more strong. And also what IBM is doing is want to foster the community by educating data scientists, engineers, using many tools like Data Science University and then evangelization, webinars, meetups. So that's really what IBM sees. Okay, hey, bring the community, show them the tools, and then educate them so that this becomes part of the organizations, and then organization starts utilizing the capabilities of analytics to empower their businesses. And then the third piece IBM is more focused on is it's infuse the portfolio, means integrate Spark into all of their products. So any product, the data-related products, their analytical products, all of them will support Spark. Currently, almost 3,000 plus engineers are working to make all their products integrate well with Spark, work well with Spark. And also, IBM started a Spark Technology Center in California, and their goal, they're going to hire top-notch 300 engineers, and their goal really is to contribute to Spark in such a way Spark becomes one of the key data science and key data enabling frameworks. And I'm not going to spend time here. These are zeros. The number of, look at here, IBM's contribution mainly, they are doing a lot of contribution in SQL and PySpark, MLlib. So these core areas, IBM is spending a lot of time. And then from a community point of view, Big Data University, anybody can go, they learn different topics and get education on. Along with this, a lot of times, right, for Spark, anybody wants to play around, setting up the environment, setting up the cluster, that would take time, particularly for data scientists who are really into the data, want to spend time with the data. That's where IBM is coming with tools like Data Science Experience, BlueMix. This Data Science Experience, really, with few clicks, anybody should be able to set up a simple cluster, Spark cluster, and start working with their notebooks. So that is a very high-level background about Spark, why the interest is. And now what I'm going to do is in the next 15 minutes, I'm going to spend on the key concepts, mainly main concepts that are making Spark an attractive to a lot of developers, analysts, and data scientists. So the key technical terminology that everybody needs to understand is Spark. Mainly there is something called Spark context, and a Spark driver, a Spark job, and a Spark stage. And under the stage there are tasks, and each task gets executed under an executor. So if you look into context is really the connection to the Spark cluster. So any application that you want to submit or you want to run, you need to get a Spark context. So you have to initiate the Spark context, and from the Spark context is what really kind of like plays into, takes your application, divides them into jobs, and then submits various tasks with number of executors you have in your cluster. So the driver is the program and the process running the Spark context and responsible for running jobs over the cluster and converting the app into set of tasks. And then job, if you look into an application, will contain multiple jobs. So job is kind of similar to query or query plan. So if you write, let's say, 15, 20 lines of code, that 15, 20 lines of code will get divided into maybe 6, 7 jobs. We will see how, from the code, what is going to be a job, we'll see later on in an example, but that's what it does. And each job, again, gets divided into stages, and each stage gets divided into an atomic units called tasks. So again, each stage made up of tasks, and one task per partition, and one task is executed on one partition by one executor at any given time. And the executor is really responsible for running the task on a worker node. So if you, from a diagrammic point of view, so if you see, so this is the application, and this is the node where your Spark driver gets initiated, and then you have other nodes where the tasks are run, which are called executor nodes. So if you see, I have one application, but I have 2 jobs, and then the jobs I have different tasks. If you see the green, hey, this job has like 4 tasks. So see how the 4 tasks are parallelly distributed. And similarly, this job has 2 tasks. Again, see how, again, the cluster manager and the Spark driver, they achieve this parallelization working among themselves. So if you look into what Spark does, a Spark application is initiated from a driver program, and each Spark application runs as a set of processes coordinated by the Spark context object, which is in the driver program. And Spark context connects to cluster manager. That's the first step it does. So the cluster manager can be a standalone, Mesos, or Yarn. After connecting to the cluster manager, what it does, it acquires the executors. Executors are nothing but worker nodes, where each worker node can have multiple JVMs. So each JVM is an executor. So what it does, hey, what are the worker nodes? What JVM instances I can run my job? That's what the Spark context does working with the cluster manager. And then once it is done, what it does, hey, these are my tasks. I know where access CPU and memory are available. So what I'm going to do, I'm going to distribute my tasks to the executors. That's the high-level architecture. If you take a job, an application, and then how various steps are. But if you get into the concepts of Spark, RDDs is a very key concept. So RDDs are called resilient distributed data set. So we will spend some time to understand what these RDDs are, because the power of Spark really is from this concept. So if you look into RDD is nothing but a distributed collection. It can be Scala, Python, Java objects, and it can be strings, integers, maps, key value pairs. So it's nothing but a collection, but it has 2 things, a couple of things that really are important to understand. One is RDDs are immutable. That means you cannot change the RDDs. Whenever you try to do some modifications in Spark, it creates a new RDD. We will see that concept in the next slide. And then another key concept is the lazy evolution of data. And we'll see them in the next slides. So if you look into physically distributed across cluster, but manipulated as one logical entity. So if you have an RDD, the data can be in 10 nodes. But for a programmer, that is a single logical entity. So when you write your transformations are actions. You write it to a single entity, and then the Spark takes care of how I work on different nodes and then bring the results back. That is taken care by Spark. So Spark will distribute any required processing to all partitions where the RDD exists and perform necessary redistributions and aggregations as well. So if you take an example, let's say I have 10 names. I'm just trying to make it simple. So I have 9 names. 9 names are on 3 partitions. So if you look into names is my RDD, so partition 1, partition 2, partition 3. So what I want to do now is I want to know the number of names in RDD name. So what I want to do, hey, I want to know how many names are there in my data set. So what I would do is, hey, I would say names.count. So that's one of the action in Spark API. So I've written code names.count. So if you look into what Spark does, it distributes this processing to the 3 nodes. So each node would say, hey, I have 3, I have 3, I have 3. And then all the local counts, they pass back to the driver program, and all of them gets aggregated to give the value of 9. So that's how Spark works, which again, from a programmer, you really does not have to worry about. And then let's look at another action. To look up the first element in the RDD, I'm going to say names.first. I want to see my first element. So the beauty of Spark is here actually. So when it says names.first, the code, what it does, it really does not, till it says names.first, it really does not load all of its data into memory. Any transformation, we'll again cover a little bit in detail, it does not load the data into memory. The data is still in partition. When you see names.first, what the program does is, okay, hey, he's only looking at the first element. I do not really have to load all the partitions into my memory. I just need the first partition, and that's what I'm going to load, and then I'm going to get the first element. So that's the lazy evaluation we will cover. That's the beauty of it. And then if you want to say, hey, I want all the names, then would say names.collect. But again, never do this in production size big data programs, because what it does is it brings all the data from all the partitions into memory. So in real life, examples, that is fine, but in real life, if you use this, it could choke your Spark cluster. So again, coming back to RDD concepts, there are mainly two concepts. One are transformations, if you look at the API, and then actions. So transformations, what they really do, they work on your data, and then they take one input RDD and then apply some function and then give an output RDD. So these are intermediate steps for your end result. But actions are where you need to give some output to the program. For transformations, each transformation, you do not have to give the output to the program. So how this works is, if you look at this example, hey, I have an RDD, I have 1 to 10 numbers, and then I want to take this RDD and apply a function on each element so that the number gets implemented. So I'm going to use the map function, and I'm going to give the function to it. What I'm telling the Spark is, okay, take each element, increment it by 1, and that creates a new RDD. So what Spark does, these steps, what it does is it creates a lineage called DAG, Directed Acyclic Graph. That means it has, hey, to achieve this action, these are all the steps that I need to do. That's the only thing it keeps in the memory. It does not load all of this data into memory yet. But afterwards, what you do, hey, I have RDD numbers 2. What I want to do is I want to get the count. Count is an action. Or collect. Collect displays all the elements to the application. So when those actions come, that's when Spark says, okay, hey, let's run this DAG and get the output. And again, the program evaluates what data it needs to load to achieve the job. So that's the lazy evolution. So there is no execution of all these transformations till you reach an action. So if you look into the program, right, how the jobs are divided into, so if the first step it sees an action, that's when, hey, all these DAG, right, to achieve this action is my job. And each job, hey, these transformations, it kind of like splits them into tasks. Hey, I need to do all these tasks. So that's the power of RDDs. And then again, it's fault tolerant because, as I say, it's going to create the RDDs are created, and once their work is done, they are flushed out until and unless you cache the RDD. And so why it is fault tolerant, if one of the node goes down, you can recreate RDDs using the DAG. So I'm going to quickly illustrate that concept. So I have a Spark context called SE. What I want to do is I want to load a text file. So if you see, that is the first, I've created my context. I want to load a text file called quotes. So I'm creating an RDD here. But if you see below, it just created a space, but it did not, this is your file. It did not load the data into the RDD. Next I said, okay, hey, I want to get the quotes that starts with that. It created another memory space, but it did not do any transformation. Then I said another map function. So I did a filter first, and then I did a map function. Again, it creates another memory space, but it does not load the data, or it does not do any work yet. So then I'm hitting a action. So now what I want to do is, hey, I want to see on this Dan Spark, I want to filter out the lines that contain Spark, and I want to see how many number of lines I have. So I hit this, then you see first this RDD is created, and then it applies a filter function. It gets these two lines, and then again it applies the Dan Spark Dan quotes map function, and then it gets the count. And then once the count is done, again all these RDDs, they are not persisted in the memory. So that's the concept of DAG. That's the concept of lazy evolution. That's what I want to spend time on. I want everybody to understand, hey, the key concept is that. That's what gives a lot of flexibility to Spark. So now I'm going to very high level spend other libraries, packages that Spark comes with. So the other key is Spark SQL, data frames, and data sets. These are very key because a lot of skill set in our organizations is SQL. So if we can bring SQL into the Spark paradigm where you can write your applications using SQL and analyze your data, it's a win-win for organizations and also to Spark. So if you look into, there's a rich set of functionality that allows database-like processing, and they also share a single optimizer called Catalyst. This is an open source extensible query optimizer. This gives a lot of power, and also it is the same engine for different APIs for Spark SQL, data frames, and data sets. And with very little code, you can achieve a lot more. So what you can do with Spark SQL, data frames, and data sets, you can absolutely take an RDD and bind that RDD with a schema, and then you can, so you get on that RDD using that schema, you will be able to run SQL statements and then get your outputs out of it, which is a very powerful concept. So the Spark SQL, data frames, and data sets make the processing much easier, bringing the SQL capabilities to Spark. So if you look into Spark SQL, so it's again, it provides a relational queries expressed as SQL, HiveQL. You can use Scala, Python, APIs, and then you can mix SQL queries with Spark programs. And if you have JSON or log files, the Parquet format files, you will be able to translate them like tables and run SQL on top of them. And if your company has already invested into Hadoop and HiveQL, it will work with Spark SQL without any issues. If you have written UDFs, SERDES, anything that you have built, they will work with Spark, and also works with Hive Metastore. And you can connect to any database with JDBC, ODBC connectivity. So relational database, you can connect to MongoDB, you can connect to any other data store out there. So the next important package is Spark Streaming. And if you look into, again, the key concept, if you look into the Spark Streaming started in 2012, and Spark 2.0, there are a very matured framework now with Spark 2.0. So the key concept in Spark Streaming is decentralized streams. So you can represent it as a sequence of RDDs, which are micro batches. And what it does, if you create a D stream on a real-time stream, like Kafka, what it does, it creates a window, and each window is treated like an RDD, and then each time frame has set of records. So again, you can use Scala, Java, Python, and you can, using on those micro batches, you can implement your logic, you can implement your analytical process on top of it using the Spark engine and get your process data out. And then Spark MLlib, again, it's a powerful machine learning, and it has the basic algorithms like classification, regression, clustering, collaborative filtering, and dimensionality reduction. And the best thing is the iterative processing is much better with Spark than MapReduce, because the MapReduce has to write data to the disk multiple times, whereas Spark, it does in memory. And then another is GraphX. So if you are like graph data you have, like social networking data, you want to take such a data and apply algorithms, Spark GraphX is the library to go. And then last but not least, Spark R. So any data scientist who is using R, again, Spark R is an R package that provides lightweight front end to use Apache Spark from R. So all the R capabilities are part of the Spark R. And then it exposes Spark API through the RDD class and allows users to run jobs from the R shell or R Studio. So this is absolutely what Spark introduction is. There are very advanced concepts that we will cover in other webinars, but this is really what I wanted to cover. Now what I'm going to do is I'm going to show the data science experience with a simple example, and then I'll open this up to Q&A. So what I'm doing is I'm actually going to my browser, and then I'm opening up so I'm going to datascience.ibm.com. I've already signed up. I have an account. So first time, if you go to this, you click on sign up, and then a minute. I'm going to relaunch it. So if you click sign up, so it's going to ask you to create your BlueMix account. So you can create this once you get a 30-day free access to the basic capability. You're not seeing my screen?
No. There you go.
Okay. Okay, so this is the sign up. You can go, you can give an email ID and you can get an access account. So I already have an account, so I'm going to sign in with my account. So you see, I'm going
We lost you
to.
again. We lost your screen again.
You lost the screen again. Okay.
It's okay now.
It's okay now. Okay. Okay. So you can see the full screen.
Yes, it works now.
Okay. So if you see the community, there are so many articles. You can go learn, take those examples and learn. And very high level data science experience, if you see, it has RStudio, it has notebooks, Python, and you can collaborate by creating projects. And if you look into what you can do is, I'm going to go to one of my projects. So I can create projects, so many projects under them. Why projects help? What I can do is I can share with other team members by creating projects. So it's really nothing but a collaboration. What I can do if I see, hey, I want to share with my team members. So this is really, you can organize your work into different projects, a pretty simple concept. And then if you go into RStudio, anybody who is a R developer, they know RStudio. So you get RStudio here, right into this. See, this is RStudio. You can working on R from your browser. You do not have to install anything. And connections is where you can create connections to many number of data stores, databases, object stores, Amazon S3. You can do all of them from connections. Object storage is, you get a, if I'm right with the basic plan, you get a 5 GB of object storage where you can store your, it's like Amazon S3, but it's on BlueMix. And then notebooks, when it comes to the notebooks, so I'm going to bring one notebook up. Which I'm going to walk you through today. So this is a Python notebook. And if you want to do the notebook, you can do in Python, Scala, R. I will show that screen. But this is one of the notebooks I'm going to walk you through. It's pretty simple. You see here, these are the two and the menus. So if you see, this notebook is divided into cells. So this cell, I wanted to show the visualization and the discussion part that I want to do, right? Hey, I can put all this text here, pretty clean. I can give all the explanations here. And then this cell, I'm writing my code. See, I just, again, basic examples, but what I can do, I can run this step by step, each cell, and see the results. And if there is anything wrong, I will be able to correct it and then retest it again. Again, I will run through this example and just giving an notebook. So the kernel, the important pieces here are, so what you do is, there are a lot of cells, and each cell you select what type of format you want to put. I want to put a markdown. Is it a heading or is it a code? And then afterwards you type either HTML or markdown or Spark code. And then if you see here, again, you can navigate the cells up, down, and then you can run the cell, you can stop the cell. But in case if you want to interrupt the kernel, you can do using this menu. So you can interrupt, restart, run all. So it's pretty easy. We'll come back what I want to do is I want to show you how, so what options we have when I go and create a new notebook. So I'm going to delete one of my things. So I'm going to one of my projects, and then what I'm doing is I am creating a new notebook. So when you launch a new notebook, this is the screen you get. You can do it from scratch. Hey, I want to do everything from myself, or I can load it from a file if I already have a notebook, or if I have a URL in GitHub, I can give the URL. So if you see, so the language selections are, you're starting from Python, Scala, and R. Those are supported at this stage. But if you're loading from a file, it's, hey, you already written that in Python, Scala, or R, which you know. So again, pretty simple UI where you go and just create a notebook. So what I would do is I will go to the example, and then I will try to run that example, and then we'll go to Q&A. So now what I'm doing is, hey, again, I wanted to display the power, so I said, okay, hey, I want to get the this with Python notebook. You do not have to create a Spark context. By default, you get a Spark context. I just want to show that. So what I'm doing is I'm running. So hey, I'm outputting Spark. Hey, you already have a context. I want to know the version of the Spark. I said SC.version. I got, hey, it's 1.60. So if you see here, what I'm doing is I'm creating an RDD. That means, again, I'm not doing any action, so you would not see any output. So if you see here, right, I see number 3, means it's already ran. It created a memory space, but did not load the data or anything like that. But if I run this, if you see, you'll get an output. It's a little bit slow because of the network where I am, and also it's the executors are smaller, so that's from a capacity wise, that's the reason why it's a little bit slow. So if you see, this is an action. When I ran the action, that's when it kind of ran this DAG, these stats, and then it gave me the output. So then what I want to do is I want to get the, again, I'm running, this is Spark code, rdd.take2, give me the first 2 records. Good. Then what I want to do is I want to create another RDD using an array, and I want to get the textual data and print that out. Again, simple example, same concept here. So now what I want to do again is same idea. See, I am creating words and then I'm parallelizing it. Again, the parallelizing means, hey, take the data and put that into multiple nodes. That's really what I'm doing, okay? So I did get me the first. Then what I am doing is I am, if you see here, words.rd2, I'm applying a map function. What I am taking each line, hey, take each line and then split that line with the space as a delimiter. So if you see here, I got a single line, and each, if you see hello class, each word is like a 1 column. The concept that I want to show here is map. There is a difference between map and a flat map. So when you use map, it's still a single line. But when you use flat map, each element that comes from the split operation becomes a new element. So if I see, hey, do the flat map and then get me the first 3, I got 3 elements. So now what I can do, similarly, I can do many operations. Hey, I want to see if there is hello in my line, okay? And I can print that out. So what I want to do now is quickly run these examples. Okay, see, how easy it is. So now what I want to do is I want to show one example where I want to load the data from a GitHub readme.md file. So what I'm doing first, I'm loading that file into my memory. Then I'm creating using sc.text file in RDD, and then give me the number of lines from this file. So I have 98 lines. Again, what I want to show is how easy it is to get your code, test, and run. So now, hey, I'd say, okay, hey, I have a problem. I want to run all of them, okay? What I want to do is I want to say, hey, restart and run all of my cells. So what it does, it resets all of them and then runs all the cells at once. So you see the output. Okay. So this is what data science experience is. In a nutshell, what IBM did. I want to explain what IBM did here now. IBM took the open source tools, Spark, or Python, Scala, all of them, and made it simple for data scientists, particularly engineers, to create an environment in few clicks and start being productive. Again, they can use their Python libraries, they can bring R and see how productivity is. So again, much more to come, but this is really what I wanted to cover today. And with this, I will open up for Q&A. Anna?
I don't have any questions at this point, but let's just wait a couple minutes. If anyone has a question, either type it on the chat window or raise your hand so I can unmute you. Guess there are no questions. Thank you so much, Rama, and thank you everyone for joining us today. Oh, hold on, a question just came in. The question is, can this be installed using IBM Big Insights?
Yeah, IBM Big Insights is BlueMix. You can go to BlueMix. There is a service, IBM Big Insights. You can do the same thing with Big Insights. But with data science experience, what you would do is you would use connections, and you will create a connection to the Big Insights and then run your work. Hope that answers the question.
Any other questions? And so this webinar is being recorded, so you will receive an email with a link to the recording in case you want to go over the materials again. The next question is, are we making the slides available to the audience? Can we make available your slides, Rama?
Yes, we will. I will give the slides, and then we should be able to make them available. Yes.
Okay, so in the email that you will receive an email tomorrow with a link to the recording. We will also make available the slides that Rama used today. Okay, this concludes our webinar. Thank you so much for joining us. And again, if you want to be invited to future webinars and meetups and other learning opportunities, please make sure you sign up at ibm.biz/datagurus. Thank you, and thank you, Rama.
Thank you, Anna.